Hello everyone, this is KP the Math G here. We are looking at the Part B of 2025 free response question number 5. Now the overall picture here is that you have a position function of x relative to h at t is equal to e to the t squared minus 4t. The velocity of j is given, and that 2 probably needs to be a little clearer right there. That or darker 1 and 2. There we go. Easy to see nonetheless, right? Vj at t. The velocity with respect to j at t is equal to 2t times t squared minus 1 raised to the third. So these are particles h and j. They're moving along the x-axis. I said in my last video, when I see one particle, okay. But when I see 2 particles, it goes, no, I don't really, but I used to go, ee. Not anymore. So we're going to go over this together. We'll see if we can get some understanding out of it. So this is Part B right here. Oops. I have so much stuff going on here. Part B. Alright, maybe I'll get through this thing. When are particles h and j going in opposite directions over t, over this interval from t to 5? Let me just, without even doing anything at all, let's just kind of give you an idea. First of all, they have to both be velocities. So let's just think about that first. This is already given as a velocity. There are times when you are doing something that you don't do anything to it. With j, there's nothing to do. Don't try to take a derivative or an antiderivative, because if you take the derivative of velocity, what will you get? Acceleration. If you take the antiderivative of velocity, what do you get? Well, you get a position equation. This is a position equation. Xh at t is equal to e to the t squared minus 4t. What we need is a velocity equation. So the first thing you need, both of these need to be velocity equations. So let's write them both down on the other side. I may have to flip the board several times. E to the t squared minus 4t. I think I might. Oh boy. Okay. Needless to say, I forgot to erase this one. And how about that? Okay, so let's see. My wife's phone loves to ring. Loves to ring. All right, let's see. I think I do have that. I did not realize that at first, but I do. But let's do it again. Gracious. There's no need in having it up there and me trying to explain through this, and then you not. All right. So let's see. Now, oh, okay. Let's erase this. I am so sorry that I Alright, I want to say that this is XH, right? X. I got it in blue. I'm so sorry. Bear with me. I don't know. It is not old age, believe me. Okay. H. I'm gonna make sure that's correct before we go any further. And we gotta have both of them. So what we're trying to do is we gotta get both velocities, and we want to know, and you have to get it to velocity because that's when the particle is moving. We don't want just a position where it is. We have to have the particles moving, and to get the particles moving, we have to have the velocity of both the particles. All right, so let's see. Let me make sure. Okay. All right. Yeah, e to the t squared minus 4t, 2t, t squared minus 1 to the third. All right. So we already have the j at t to be equal to 2t, alright, times t, I want to say t squared minus 1 cubed, alright, like that. Okay. I think that's correct. Let me double check it again. Sorry I had my back turned to you. And from all intents and purposes, there it is. Okay. Now, let's take a look at it. Let's get this derivative here. This is sitting stationary. We want to get it moving, right? So we need to find velocity. So, okay, so x prime h at t gives us the velocity h at t. And you got an h down here. You want to put it over here, right? Right now. Remember, do not just say e to the t squared minus 4t and not do any more to that. So that is not true. That's not a true statement. Just a little thing here. The derivative of e to the x is e to the x actually times the derivative of x, which is 1. So there is a real chain rule. We don't put the 1 there, it's just e to the x. So e to the 2x will be e to the 2x times the derivative of 2x, which is just 2, right? So e to the 2x times 2, which is 2 e to the 2x. So that's really how you do it. It's really a chain rule with e, especially if it's not e to the x. So we're not done with this derivative. Times, now the derivative of this, t squared is just 2t, right? And the derivative of 4t is just 4. Alright, now we have this. We have it, don't we? Both of these are here. Now, what we got to do here is, it's going to be a lengthy thing here, so we're just going to have to, bear with me. And I drive a bus in about 22 minutes, so now 21 minutes. So I have to get on with it, but just to kind of show you. Now, let me say something here. E to any power, it does not matter whether it's positive or even negative. E to any power is always positive. This is equal to 1 over e to the 100, but e to the 100, that's going to be close to 0, but still, that is not going to be 0. It's still a number. It's always positive. So E is always positive. So just don't let this box. So what we got to do is we got to find out where this comes to rest. So what we're going to do is we're going to say this. We're going to start with this one first and then this one. All right. So first of all, e to the t squared minus 4t is already greater than 0. It's positive. Positive. So let's not worry about that one. 2t minus 4 is what we concern ourselves with. Let me put it over here because I know I'm going to need room. Okay. So 2t minus 4 is equal to 0. So where does it come to rest? All right. So first get your velocity. If you don't have it, you have this one already. You just needed to get this one. Then say, okay, it's always equal to 0, greater than 0 here. On that interval from 0 to 5, it's always going to be positive. This here, we solve plus 4, 2t is equal to 4, and then I divide by 2, t is equal to 2. Alright, so let's set it up. Alright, remember our open interval is from 0 to 5. We know that t is equal to 2 when 2t minus 4 is equal to 0. Okay. Alright, I hope you can just see that see the answer without doing this work too much. So, okay, so what we're going to do is we're going to have something for h. Alright, here's 0. Here's 2. And we're going to go all the way to 5. So, I think maybe we'll just go all the way to 5. So, alright, let's put this up here. 2t minus 4. Now think about it. If you plug in any number to the left of 2, let's say 1. 2 times 1 minus 4. Always checks a number to the left and a number to the right of 2. Of the 0, you know, right here. Alright, so 2 times 1 is 2. And 2 minus 4, we don't care about the answer. The answer is negative 2, but the answer is negative. So everything else in between here and here will be negative. So let's see. Alright. Will be negative. Well, we are looking at h, right? Be at h. Be at h, right here. Alright. Negative here, and just automatically, without thinking, you can put a 3 here. 2 times 3 is 6. 6 minus 4 is 2. Everything after the 2, 0 is going to be here. Will be positive. Positive, 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 positive. Now, what does negative and positive mean? If you're thinking that the particle's going left from 0 to 2, you are absolutely right. And these positives mean that the particle is going to the right. Particle is moving to the right when we're going greater than 2, in between 2 and 5. Alright, so that's that one. Alright. This is the main thing you have to concern yourself with, because this, again, is always positive. And just keep that in mind no matter what you got up here. I know there's a minus sign here. I don't care. I don't care that I have a minus sign here. This e to any exponent, well, it's not going to ever be negative. You can put a negative exponent up there. It's not going to be negative. Alright. So don't worry about this part, just this part right here. All right, now let's go with a different. I'm going to try to do the same thing here. 0 here, and we're going to look at V at J, right? 0. We're going to put 2 already, and we're going to go all the way to 5. I gotta keep my eye on the time. We've got 15 minutes, so all right, bear with me then. Make this line a little darker. All right, there it is. Not gonna look pretty, but it's all right. We got it. All right, so from 0 to 2, 2 to 5. Now let's look at it. Now here's J. Here's another thing. 2t. If 2t is equal to 0, then if we divide by 2, right, we're setting the factors equal to 0. Well, let me do it right. Okay, 2t times t squared minus 1 cubed, okay, is equal to 0. Alright. Really, we say that 2t is equal to 0, or t squared minus 1 is also equal to 0, right? Okay. We know if we divide this by 2, t is equal to 0. So if we plug in anything t greater than 0, everything's going to be positive right here. So if we put 2t right here, everything's going to always be positive, just like this e to the, yeah, this is always going to be positive. Okay. We can put 2t right here, and we know it's 0. Everything all the way across from 0 to 5, you plug it in, it's going to be positive. Okay. That means it's always going right, 2t. Now we also got, oh well, we could put cubed up here, but okay, here's what I'm saying. If we take the cube root of both sides, alright, then we just have t squared. If we take the cube root of both sides, alright, then we just have t squared minus 1. That's really all we're worried about right here anyway. T squared minus 1 is t plus 1. Remember, you can factor that. Times t minus 1 equal to 0. Right? So t plus 1 is equal to 0, which means that t is equal to negative 1. And then t minus 1 is equal to 0, which means that t is equal to positive 1. Time cannot be negative, so we're going to mark that out. So t is equal to 1 here. So what we're going to do is, t is equal to 1. I'm going to put a 1 here. I'm going to put a 1 on both of these. So 1. And we got a 1 on that one. I might as well put it on that one too. Okay, right here, 1. Alright, 1. Now let's think about it. Let's just concentrate just on t minus 1. Okay, t minus 1. So I'm going to erase the arithmetic here once again. Alright, we're down to just t minus 1, really. I'm just going to erase all this. So right here, t minus 1. T minus 1. Okay, we can't worry about the cube. We just took the cube root and got rid of that. So really, we're just looking at t minus 1. Now, if you pick a number to the left of minus 1, let's say half maybe. A half minus 1 is certainly negative, isn't it? It's negative 1/2, isn't it? All right. So negative 1/2. So everything to the left of 1 is negative. So that means particle is going to the left. And a negative times a positive is still negative. So we really don't need, if everything's positive here, I don't know, we really don't need this. So we can leave it there if you want, and you'll see that it'll turn out the same either way. Alright. So everything to the right of 1, automatically just start putting plus signs. So we know from 1 to 2, it's moving to the right. And actually from 1 to 2, this one is moving which way? 2t minus 4. This one's moving to the left also. So from 0 to 1, it's moving to the left. From 1 to 2, we're moving to the left. This one's moving to the right. And everything else from 2 on is going to be to the right. So if I plug in a 3, 3 minus 1 is 2. Alright, so once you start putting plus signs here, just go ahead and put them boom, boom, boom. Most of the time, it's going to always be plus. So both of these, so let's look at it. So we have 3 intervals, 3 different intervals. Now, let's understand something. When are our 2 particles going in opposite directions? When one sign is negative and one sign is positive. Both of these are negative. They're both going in the same direction. They're both going left, right? From 2 to 5 on that open interval, both of them are going right. So in between 1 and 2, this one's going left and this one's going right. Alright, so on the interval, you got to say something now. You can't just leave it like this. Okay, it looks good, but you need to let them know what you're saying here. So on the interval, let's just write it. So on the interval, got 8 minutes. On the interval, from 1 to 2, where t is between 1 and 2. And by the way, you can also write 1 on the open interval, 1 comma 2. Open because if you block it in, it's a closed interval. If you put parentheses around it, it's an open interval. That's not at the point 1 comma 2. So a lot of times, to make that distinction, we put t between 1 and 2, just like that, less than symbols on the interval from 1 to 2. Particle H is moving to the left. Let's just say left. Moving left. And particle and a particle J is moving right. Ooh. We move out of the way here. Alright, moving right. Or you can say on the interval law, you can say particles H and J are moving in opposite directions. Alright. You can say on the interval from where t is between 1 and 2, be it h at t is less than 0, and the j at t is greater than 0. So obviously they're going in opposite directions. You can say a number of things. Any of those will be sufficient, or should be anyway. Less than 0, negative, moving to the left, and this is going to the right, and you can do that. So anyway, that's, I'm just going to erase it just kind of so it won't look so cluttered up. But there it is right there. It is always wise to remember that if you're looking at two particles, both of those equations need to be in terms of v. If neither one of them were, we would have to take the derivative of both of them. We didn't have to do j. J's already taken care of. Set them equal to 0. Find out where that stops. Okay? See, this one is moving to the left, stops after t is equal to 2 seconds or whatever, minutes. Now it's moving to the right. Alright? This one here is moving to the left after 1 second. Oh, left. Okay, so, well, I'm going right, so okay. Well, on the number line, going by the number line, left, and then 1 second later, well, I mean, instantaneously, turns, stops and turns, and moves right. But this one does not turn right until after 2, but this one turns right just after 1 second, whatever, second, minute, hour, whatever. That's what that means, though. Okay? Velocities, set them equal to 0. Remember, anything e, forget it, positive. This part's good. We did it, the 2t part is always positive. Matter of fact, if you left it alone, always positive. Boom, boom, boom. Always positive. Okay. And you could say a negative over positive is, or negative times positive is negative. Positive, positive, positive. And then positive the rest of the way. You could do that if you want to. This one's always positive here on E. But anyway, be that as it may, you still have the same result. So alright. This is all you're worried about here. And this part, well, this part right here on this one. So that's it. A little bit of thought there. But it does help. If you're going to put these graphs here, I mean, well, if you're going to put the number line here, stack 1, and you can easily see where, when I see, oh, left, left, same time, right, right, oh, left, right, on the interval from 1 to 2. And that's how you do it. Okay? Well, that's a lot to absorb right there, but it's very good stuff. And in about 2.5 minutes, actually 1.5 minutes, I'll be going. I actually drive a bus now. I don't teach anymore. I drive a bus. It's not a lot of money, but it makes a little bit. Matter of fact, we got paid today, so that was really neat. And you know, not that I really need the money, but it does help to have it. And boy, it's really, life is pretty nice right now. So anyway, KP the Math G, getting ready to sign off. Remember, if you have not subscribed, I'm going to tell you this time, I have 99 subscribers. I need one more subscriber. If I stay with 99 for the rest of my life, so be it. It's all right. It's not about me. It's about you. The like button, I love it. Makes me smile when I even say it. See, yeah. It's not a fake smile, really. Anyway, I love the like button. And if you'd like to make a comment, I've gotten some good comments. I'm not going to state what they are. I'm just going to say Got some good comments, and I really do appreciate those comments. Now they're short, but hey, I like that, and that is encouraging to me, you know. So, and I feel real good about it. So, but if you don't do any of the above, so be it. Again, this is for you, not for me. But it sure does keep my mind sharp. A 65-year-old mind real sharp here, and I'm enjoying this. Okay, I enjoy doing this. This will be the 172nd YouTube video, all calculus based. Okay, so anyway, KP the Math G signing off. Ladies and gentlemen, have a great day.